All right, number 3. So we have a very similar situation to problem number 1, but notice we're not here. Now our height is here at the end. So we begin with all elastic energy as we did before because V is 0 and H is 0, and we do see a spring. Now notice though, since we're not as high up, what this means is that we have less gravity energy than before. We still have gravity energy, but it is less than before. And we do have speed, so let's be clear, we only have 2 bars of gravity energy now. I just lowered it by 1 bar because it's easy to draw on a graph. And what this means is that in order to have 4 blocks of energy at the end, we need 2 blocks of kinetic here. So we'll kind of write it like that. So what this tells us is that our elastic energy gets converted into kinetic and gravity. Question number 4 is the same as 3, but now we have friction. So it's going to be a very similar situation. Once again, we have all elastic energy as height is 0 and V is 0. And notice here we have a speed greater than 0. We have a height greater than 0. We have no friction. And so what this is going to give us is elastic energy gets converted into, and we have dissipated energy. So we have the same height as we did in number 3, so I'll give us the same gravity energy. Now we have some dissipated energy, which I'll draw here. And we have some kinetic energy here. So this is going to tell us that the elastic energy gets converted into kinetic plus gravity plus dissipated. All right. Now, this problem here, y is just another word for elevation or height. I hope you could figure that out. I think it's natural for me, since this is the y-axis and it's drawn here, I think it is reasonable for me to expect you to be able to figure that out. So, yeah, our height is 0, our speed is greater than 0. There is no friction. So what this tells us is that we start off with all gravity, and then we roll up a hill with no friction, so we have height but no speed. You know what? Let's be clear. No, it's not all gravity. We have speed but no height. So this tells us that all of our energy is in fact kinetic to start with, and it gets converted to all gravity at the end, so we're going to have kinetic getting converted into gravity energy. For number 6, we're going to repeat the same problem with friction. And that's going to alter things slightly. So we have all kinetic to start with, and we lose a little bit of energy too, so we're only going to have some gravity, and the rest gets dissipated here. So when we set up our equation, we'll have E kinetic equals E gravity plus E dissipated. Now, a couple of students had actually asked me about this. And here we're going to assume that this person is like a spring. So what this means is we have all elastic energy stored in the person. There's parking brake. That means that there's some dissipated energy. And we have some height, but no speed at the end. So what ends up happening is that our energy gets distributed between gravity energy and dissipated, like that. So when we set up our equation, it's going to be all elastic getting converted into gravity plus dissipated. This last problem, we have no friction, and it should be straightforward. No height. No, I know you see height here. I don't care. They're telling you that YA is 0 and VA is 0, so we start off with all elastic. And it gets converted into a combination of gravity and kinetic with no friction. We see height and movement. So then we have elastic converted into kinetic plus gravitational. And that is questions 3 through 8, so I hope that was helpful.